We often watch well-intentioned educational reform efforts completely stall out, despite significant infusions of both time and capital. The standard policy playbook relies on a linear assumption, pouring resources into a single category, like funding or teacher training, to produce a proportional increase in student test scores. Classical organizational theory suggests this is an oversimplification. Schools operate as complex, interdependent social systems. This creates a diagnostic problem. If schools are intricate webs of human and structural variables, linear mathematics lack the precision to identify why a specific institution is failing. To achieve sustainable improvement, we must move beyond isolated metrics and map the entire organizational ecosystem. Mapping this complexity requires a highly specialized approach, much like the research by Yamsafa and colleagues examining secondary schools in Thailand's Roy Et region. To solve the problem of measuring multifaceted causal links, the researchers utilized structural equation modeling, or SEM. By deploying SEM, they constructed a mathematical model capable of explaining 89% of the total variance in overall school effectiveness. The data indicated that organizational context and leadership exert a structural influence that significantly outweighs isolated teacher or student traits. Reconstructing this powerful structural model from first principles reveals exactly how a high-performing school is actually engineered. The initial methodological hurdle is quantification. Before mapping a system, you have to assign hard numbers to abstract concepts like leadership or school culture. Researchers began by collecting data across 20 observable indicators using structured questionnaires distributed to educational administrators and teachers. They then applied confirmatory factor analysis to group those 20 data points into 5 distinct latent variables, specifically administrator, teacher, student, school factors, and school effectiveness. This table verifies the statistical stability of those groupings. The construct reliability column shows every value exceeding standard benchmarks, resting above 0.93. In the adjacent column, the average variance extracted lands significantly above the 0.50 threshold. Confirmatory factor analysis validates that these 5 latent variables are stable, quantifiable constructs, allowing the researchers to test how they interact. With the variables established, the next step is plotting their theoretical relationships. This diagram illustrates the conceptual framework. The flow moves from administrative and school variables through teacher and student factors towards school effectiveness. Structural equation modeling computes these causal pathways simultaneously, feeding in the empirical survey data. The result is a validated causal structural model of secondary school effectiveness. It provides a visual map of the computed path coefficients. This specific configuration of pathways maps the precise numerical flow of influence throughout the school system. From a strict statistical perspective, we have to verify that this web accurately reflects the empirical data. This table presents goodness of fit indices against academic benchmarks. While row 1's chi-square is sensitive to large samples, row 2's relative chi-square sits at 2.933, clearing the threshold. Further down, the CFI reaches 0.968, and the RMSAA rests at 0.077. Because these indices clear stringent academic thresholds, policymakers can trust this model as a scientifically valid representation of school dynamics. Examining specific pathways identifies the system's most powerful nodes. Administrator factors are the most potent, with variable AD4 carrying a 0.93 structural weight. The second most powerful is school factors, where variable SC4 commands a 1.00 factor weight. The empirical data demonstrates that strategic leadership and organizational culture function as the primary causal drivers for the entire school system. Teacher and student factors possess a clear direct impact on overall school effectiveness. However, the structural hierarchy reveals teacher and student factors occupy a secondary tier of influence. The primary leadership and contextual nodes act as core enabling conditions. They shape teacher efficacy and student learning behaviors before those groups influence the final outcome. Efforts to maximize teacher quality or student engagement will struggle to succeed unless the organizational container they exist within is optimized first. Form initiatives are mathematically likely to underperform. Sustainable quality improvements require shifting resources away from isolated terminal nodes and redirecting them toward the root of the system. The data suggests prioritizing the development of administrators' strategic leadership and change management capabilities. Simultaneously, district planners must optimize internal administrative processes and working conditions to ensure robust staff collaboration. True educational excellence is an engineering problem, one solved only when leadership and context are integrated as the center of the system.